Example 7.13 will again ask for a numerical verification and will also ask us to relate the identity 1 plus tan squared theta equals secant squared theta to our original Pythagorean identity. Let's start with the verification. We'll replace each instance of theta with 60 degrees. Note that common strategy of rewriting in terms of sine and cos appearing again. Now we'll use our unit circle to determine the values of sine 60 and cos 60. We know that sine is the y-coordinate and cos is the x-coordinate. Dividing root 3 over 2 by 1 over 2 is equivalent to root 3 over 2 multiplied by 2 over 1. The 2's will reduce. So our expression becomes 1 plus the square root of 3 squared. Now let's evaluate secant squared of 60 degrees. Secant is equivalent to 1 over cos. And as we already determined, cosine of 60 is 1/2. 1 divided by 1/2 is 2, which squares to give us 4. We've shown that both sides of this potential identity are equivalent. Now, I should say here that this is a known and proven identity, but that typically when we're verifying, we consider it to be uncertain. Just add a little bit of excitement. In order to show this as the original Pythagorean identity, we'll divide each term by secant squared. Given that secant is 1 over cos, secant squared will be 1 over cos squared. Similarly, tangent, which is sine over cos, will square to become sine squared over cos squared. Secant squared divided by secant squared will reduce to 1. When we divide by a fraction, it's like multiplying by its reciprocal. We see that happen twice here. Our equation simplifies to cos squared plus sine squared equals 1 and confirms that this is another version of our Pythagorean identity.